Consider this complex ion. He says FeCN 6 times minus 4 is diamagnetic. Since it is given as a diamagnetic, naturally there is no unpaired electron. All right. 4 options are given, and of these 4 options, which is true and which is false? Now, a discussion on CFT or any theory of bonding in complexes. We will come across several terms: outer orbital complex, inner orbital complex, and corresponding to this we have various hybridization effects. Now, let us find out these options. According to option A, this is an outer orbital complex. Outer orbital complex means sp3 d2 hybridization should be present. But cyanide ligand is a strong field ligand. That is why the electrons are paired, resulting in the diamagnetic property. If electrons are paired in d orbitals, it cannot be an outer orbital complex, it will be an inner orbital complex. So, A statement is not true, it is false. FeCN 6 times minus 4 is an inner orbital complex. All right, option B, its hybridization is sp3 d2. It is also false. I have told you it is not an outer orbital complex, but it is an inner orbital complex. Inner orbital complex means d2 sp3 hybridization and not sp3 d2 hybridization. So the second statement is also false. Third one, it is a spin paired complex. You see, it is given as a diamagnetic compound. Diamagnetism means all the electrons are paired. There is no unpaired electron. Now, there are several terminology. One is a spin paired complex. Spin paired complex means all the electrons are paired. Then only it will be diamagnetic. So, since it is a diamagnetic, it is a spin paired complex, it is true. Third option is true. What about the fourth one? It obeys Hund's rule. You remember Hund's rule of maximum multiplicity. Hund's rule of maximum multiplicity says if you have a set of degenerate orbitals, the electrons should fill these orbitals singly. Pairing immediately does not take place. But here the electrons are paired. That means there are vacant d orbitals. But it means option 4, it is also false. That is, Hund's rule of maximum multiplicity is not obeyed in the case of this diamagnetic complex FeCN 6 times minus 4. Do you follow? So, from these 4 options, only one option is said to be true, namely a spin paired complex. For diamagnetic species, we can also say it is a spin paired complex. For paramagnetic species, we say spin free complex. Spin paired means the electrons are paired. Spin free complex means there should be at least one unpaired electron.